Hello everyone, welcome to the session. So in this particular session, we will talk about that how we can compute time complexity if suppose something like while loop is given to us in our code. Okay. So in the previous video itself, we have seen that time complexity is nothing but it's a order of magnitude of a statement. Means how many number of times any statement is executed. So with that particular concept keeping in our head, let's get started. Now, let me take few more examples here for demonstration. So again, what we are doing is that we are trying to do the a priori analysis in this session as well, right? So let's get started with another example. 3 examples I remember we have covered up in our previous part. So today we will start with the example number 4. Okay, let's get started. So here suppose again some main function is given to you. Inside that they are saying that the value of I is equals to n. And I am saying that while, I hope everyone knows how while loop will work. Inside the while loop we will write some condition, and until or unless this condition will be true, it will go inside that statement. So we are saying while the value of I is greater than 1, right? So at that point of time, just do one thing, decrement the value of I by -1. Suppose this is the code that I have. Consider that the value of n is small. Just for the demonstration purpose, let's take another small value, which may be 5. Okay. Now what will happen is that how while loop will work? It will check the condition. If the internal condition is somewhere true, then it will go inside this statement. And we have to just check that how many number of times the internal statement will run. So if the value of n is 5, so 5 is greater than 1. And at that point of time, the value of I will become 4. So the value of I will start from 5 only, because we have mentioned in the first statement that the value of I is something which is equals to the value of n itself. Okay. Now again, when the value of I is equals to 4, so again we are checking 4 is greater than 1. Yes, it's true. Now the value of I will again decrement by 1 and it will become 3 now, right? Great. Now the value of I will become 3. 3 is again greater than 1. I value will get again decremented. So the third number of time it is going inside the while loop and the same statement will run, and now the value of I will become 2 now. Now again this 2 value, which is the value of I, is again greater than 1. It's so true. Now again what will happen is that because this is true, the value of I will become I minus 1, which is 2 minus 1, which is equals to 1, right? So now what will happen is that when the value of I is equals to 1, is the value of 1 is greater than 1? Is this condition is true? No, this condition is somewhere we are getting as false. And once we will be able to get this condition as false, it will not go inside the while loop. And that's where the internal statement will not get executed, right? Internal statement will not get executed, and now the value of I will not become 0. How many number of times the statement will get executed inside the while loop? This is the first time, right? Second time, third time, and fourth time. Means when the value of n is equals to 5, we have seen that 4 times the statement is executed. You will observe that when you put the value of n as 10, try to do it at your home, 9 times the internal statement is executing. It means when the value of n is some random number n, internally how many number of times the statement is executing? Can I say it will be n minus 1 time? Can I say the statement? Right? Just by observing the above pattern. It means what is the time complexity? Order of magnitude of a statement. How many number of times a statement is executing? N minus 1 times. So I can say that the overall time complexity is big of n minus 1. Why to take the constant as well? We are talking about approximations. So it will be equals to order of n. Very, very important, right? This is the way to approach about the time complexity. Let's talk about another example, example number 5. I hope with every example, you are able to get a better clarity about the computation of a time complexity. Okay, suppose again I am saying that there is a main function, and inside that main function, the value of I is equals to n. Now what I am saying is that while the value of I is greater than equal to 1, right? Do one thing. Do one thing for us. Try to just decrement the value by 2. Okay? Try to just decrement the value by 2. So this is the condition which I am talking about of the while loop. And if that condition will become true, obviously it will go inside this while loop and will run the same. Now again, let's take one example. Just very simple example. Let's take the value of n as 10. So the value of 10 is greater than equals to 1. That's true. So the value of I will become, so initially the value of I will become 10 only because the value of n is 10. So it will be 8. Now again the value of 8 is greater than equals to 1. Again condition satisfied. So the value of I will become 6. Again the value of 6 is greater than equals to 1. The value of I will become 4. Again the value of 4 is greater than equals to 1. So the value of I will become 2. Again the value of 2 is greater than equals to 1. The value of I will become 0. Now here if you will observe, at every iteration this condition is true. That's why it's going inside the while loop. Now when the value of I is equals to 0, it will again check is the value of 0 is greater than equals to 1. This is where condition will become false. This is where the condition will become false and it will not go inside that while loop. So the statement will stop executing at this point of time. At this point of time. So how many number of times the statement is executing? 1 time, 2 time, 3 time, 4 time, 5 time. You will observe that, so we have seen that when the value of n is 10, the statement executes 5 times. You will observe that when the value of n is not 10 and is 100, at that point of time, the statement will execute 50 number of times. What I want to say, when the value of n is n, the statement is executing n by 2 number of times. It means that the time complexity is nothing but is equals to order of n by 2. In terms of big O approximations, it can be written as order of n, right? Order of n. Similarly, if I type here, instead of I minus 2, if I will say that the value of I is equals to I minus 3. At that point of time, what is your answer? At that point of time, obviously, it will run until n by 3 times. And when it will run until n by 3 times, again the time complexity will remain same, order of n. But how many number of times at that point of time it will execute n by 3 times? If that's the statement instead of the above one, right? If suppose both of the statements are included inside the while loop, okay? At that point of time, cumulative, your value of I will decrement by 5. So at that point of time, it will be n by 5 times. And at that point of time, the time complexity will be again order of n. So here if you will observe, at every time, the time complexity will remain same, which is big O of n only. But at each and every time, how many number of times internally the execution will happen? How many number of times internally that statement is executing varies a lot. And that's where you have to see. That's where you have to understand. And that's how we can compute the time complexity. It's just that you should have a good knowledge of the looping, how and why looping will work. After that, it's very easy to find out the time complexity part. Okay, so I hope that this part is pretty much clear to everyone. As a brief note, whatsoever we have discussed in our previous session and in this session, what we can conclude here? What we can conclude here? The very first thing which we can conclude is that whenever we are talking about a time complexity, we have observed until now that time complexity is loop only, right? So whenever in your code you are having some sort of loop, it means that you can have the higher time complexity. Higher the loops that you are making in your code means you are increasing your time complexity, right? Even not only about the loop, I should say that it will be a higher loop. If you remember, in our example number 2 that we have discussed in our previous video, we have seen that n square plus n plus 1. And what I told you, what is the higher exponential? And you only, I hope everyone said that it's n square, right? So it's order of n square. That's why the higher loop, that's why the time complexity is order of n square. After that, if suppose in your code there is no loop at all, if suppose in your code there is no loop at all, it means that you are dealing with a constant time complexity. And how we can denote that? That also we have seen in our sessions, which is order of 1, right? We are dealing with a constant time complexity, which is nothing but order of 1. These are the 3 very important key points to note whenever we are talking about the time complexity. And that's what I hope everyone is able to understand with this session and the previous one as well. Both together, if you will see it, you will be easily able to observe and understand how basically we can evaluate the time complexity aspect given any code. So I hope that the portion is pretty much clear to everyone. With this, I would like to end this session. Happy learning to all. Bye-bye everyone. See you soon in the next upcoming session.